Hello. Today we are going to look at a trigonometric version of Pythagoras' equation, and it is a very important identity that comes up in lots of different parts of problem solving in more advanced trigonometry. So this is our identity that we are going to be deriving. We have cos squared of an angle plus sine squared of the same angle will always equal 1. There's no caveat to this, it's always true. And we have this rule that we are going to use quite often on the top right hand corner of page 13 in our log tables. So we're going to look at where this rule comes from. And as often happens when we're trying to do advanced work in trigonometry, we are going to rely on the unit circle. So a circle centered at the origin with a radius of 1. That's going to help us to understand the more complicated relationships and behaviors of our trig functions. So if we imagine that we have a point on our circle and we say its coordinates are x and y, well, because we're centered at the origin, that means that we have gone from the origin across by x and up by y. And we know, because we are on a unit circle, that the radius is going to be 1. Well, if I do my walking across and walking up, I can see that I immediately trace out a right angle triangle. Again, why our unit circle gives us information about trigonometry. So what I want to do is be able to describe my x and my y in terms of sine and cosine. And that is almost immediately going to give me the relationship that I am looking for. So let's have a look at how we could define cos of my angle A. Well, that would be the adjacent divided by the hypotenuse. Well, the adjacent of my right angle triangle, as I've drawn it here, is x, and the hypotenuse is just 1. So that's x over 1. So immediately we can write down then that the x coordinate is going to be cos of A. And can we do something similar for the sine coordinate, for the y coordinate? Well, it's going to be the opposite over the hypotenuse. So that is going to be y over 1. So the y coordinate on our circle, on our unit circle, is going to be sine of A. So I could rewrite that coordinate as cos of A sine of A. And that is just as valid a way of writing my coordinates of my point. So this is now telling me either y is equal to sine A and x is equal to cos A. Well, that means I now have a right angle triangle. I draw in a rough sketch of this with a hypotenuse of 1. One of its sides, I'll draw in A here, but I don't need it. Y is equal to sine of A, and x is equal to cos of A. Well, what do I have that relates the three sides of a right angle triangle? I have Pythagoras. So x squared plus y squared would be equal to 1 squared. So a squared plus b squared would be equal to c squared, or h squared, depending on how we learned it. And now we can substitute in our trigonometric version of this. Cos of A is our x to be squared plus sine of A for our y to be squared. 1 squared is just 1. And the way that we usually write cos of A squared is cos of A squared plus sine of A squared is equal to 1. So all that we have to do for this derivation is take the unit circle, use that to get our x and y of our right angle triangle in our unit circle, in terms of our trig functions, and then by writing down Pythagoras, we immediately get the solution. So that's why this is Pythagoras in trigonometric form. And that is what we need for now.